Hello, this is Dr. Rudabaugh, and I was a little bit rambling on video two because I really wanted to show you some concepts of plate tectonics, and I didn't have the map up of the plates. So what I'm going to do is have a short video here that really covers some of the concepts that you will need to understand for the themes that you will see in crustal formation processes, mountain building, earthquakes, volcanism. And I'm going to really focus in on a map and showing you some graphics that I think complement the lecture or the readings that you'll have in these last sections here of chapter 10, because what I really needed there was a series of maps. And this map here is really what I wanted to start the lecture off with the second lecture in chapter 10, which is a map of the actual individual plates, and the fact that each one of these individual plates sort of has its own mind in terms of how it moves and interacts. These plates, as we know, are not stationary through continental drift theory. We talked about that the mantle beneath these plates and the Earth's solid crust are swirling around and causing these plates to grind up against one another in certain places, and they create what are called plate boundaries. And what I wanted to show you is obviously here we are on the North American plate, but depending upon where you live on the Earth, you literally could be moving in a different direction. But our modern understanding of geology is how these plates interact along their boundaries with each other is what creates so much of the geologic phenomena that we see and associate on Earth today. So, for example, I'm going to show you this map right in here, or maybe this one would be even better. This map here is the one I really want to get at. And this map here shows you that effectively around the Earth, these little triangles here show you where active earthquakes and volcanoes are occurring. And when you begin to examine these patterns, you could so vividly see how there is a connection between where earthquakes and volcanic events are occurring in relation to these tectonic boundaries. In this map in here, we really could talk about two primary types of boundaries, but I wanted to briefly show you that in this little picture here, there's really a variety of different types of convergent boundaries of where we see like oceanic plates converging with oceanic plates, or we could have continental plates converging with continental plates. And so these are two examples of convergent plate boundaries, and they both are associated with wherever we see two plates converging, we often see mountain ranges and active volcanism. And when you go back to the diagram here, you can see in this map here, any areas where you see blue lines, these are areas where we see plates converging together, whether oceanic to oceanic or oceanic to continental or continental to continental. And if you'll notice, this is where we see some of the most active volcanic mountain ranges on the planet, or where we see these associated convergent plate boundaries. In contrast, we have what are called rifts or divergent plate boundaries. And rifts or what are we called mid-oceanic ridges are very good examples of two places where we see divergent boundaries. And on this map here, those are identified by the red lines. And usually we find these usually on the bottom of oceanic floors. And they basically are spots along the oceanic crust where the Earth is being pulled and rifted apart and spreading into two separate parts. And that's where, if you look at the Mid-Atlantic Ridge, the one part of the plate is going one way and another plate is going the opposite way. So for the example here, the mid-Atlantic Oceanic Ridge is actually causing Africa and Eurasia to move one way and causing the Americas to push out and go the other way. And the Mid-Atlantic Oceanic Ridge is that's what is effectively creating The mid-Atlantic ridge is what is effectively creating the Atlantic Ocean. I think I said the Pacific Ocean, and I wanted to correct that. So this ridge here, by pulling apart the ocean floor there, is creating the Atlantic Ocean and creating the African and Eurasian plates, and they're moving in one direction, and the North American and South American plate are moving another. So to act upon what we've just learned, we could really then apply plate tectonics to understand so much now of what we're talking about with like earthquakes. When we study earthquakes, there are a specific pattern to the whole process is that we see where they occur on our map. You could literally see that the earthquake patterns and frequency and their this dot pattern on this map is almost perfectly aligning up with where the tectonic boundaries are. And they're very common in areas where you actually see earthquakes occurring along what are called transform faults, where one plate is sliding one way and the other plate is sliding by it another direction. And that's why when we look around the rim of the Pacific Ocean, we see a lot of this type of activity. And this is why earthquakes are so specifically geographic, that the earthquakes are occurring around the world, literally around boundaries where plates are grinding past one another. And then, ironically, is where plate tectonics is set into motion. So literally the study of earthquakes is literally the study of how tectonic plates are starting to move and grind by past one another. And there's a variety of ways that we talk about them in terms of measuring their strength, how deep are they, and the energy that travels when the plates do slide by one another. Seismic waves are created, and we call them P&S waves, and you'll have a lab on those of understanding how you could use P&S waves and how fast they travel to understand where the epicenter of an earthquake occurs. So when we study earthquakes and we study them using the Richter scale, you'll actually figure out by looking at seismic waves where they originated from and locating the epicenter of where an earthquake occurred. But here's even a prettier map to show you the dot pattern distribution of where earthquakes are occurring in relation to tectonic boundaries and plates. And you can see so nicely how they occur. And literally, the study of earthquakes is literally corresponding to the modern studying of plate tectonics, because so many of them are occurring along the edges or boundaries where plates are grinding past one another and what is called a transform fault. And here's an example of one right here where we have two plates meeting. One's going one way, one is going the other. When the plates slip and slide past one another, that's called the epicenter and focus of the earthquake, and that begins to release energy stored in the Earth's crust in a series of waves. And these are the waves that do the destruction and devastation to the Earth in terms of the magnitude and strength and the depth of the earthquake. So any area where you're living near a transform fault where you've got two tectonic plates that slide by one another, the most famous one in America is the San Andreas Fault that goes through Southern California. You're in an area that's very vulnerable to earthquakes destroying and devastating your landscape and development and construction. So here's a magnitude showing you how to read the Richter scale and a variety of other maps there. And I'm going to go ahead and hit back. And the last thing I want to show you is volcanism, and that's as far as I will get with this presentation. And just like earthquakes, volcanoes are very, very closely corresponding to where tectonic boundaries are as well. And they tell you volcanoes are generally associated where we see convergent plate boundaries occurring where plates are slamming into one another, almost like two cars in a crash. And where those happen, one plate is thrown underneath the other one, and I'll show you a picture of that here in a second. Let me see if I could find you one. I'm going to see if I could, I'm going to get back onto here and see if I could find you. Earthquakes are going to occur where we see a convergent plate boundary and where either it's oceanic to oceanic or oceanic to continental or continental to continental, one plate is thrust under the lighter one. The heavier plate is thrust down in the mantle, and that rock then begins to melt. And then that magma is then going to float up through as it melts. It will become lighter than the surrounding rock, and that melted rock will then rise up. And then, if it punctures the Earth's surface and fractures it, it becomes an active volcano and releases that molten lava, which is now magma on the Earth's surface. There are a variety of types of volcanoes, depending upon if we talk about shield volcanoes versus composite or cinder cones. And in your readings, I'll go back to there real quick, see if I could find it. Here it is. There's a variety of different types of volcanic explosions, but whether you're in Hawaii and you have shield volcanoes, or you have cinder cones, or you have composite volcanoes, it's a very good YouTube video to understand what are the difference between shield volcanoes and composite volcanoes. And they'll start talking about what type of plate boundaries and what type of rocks kind of go into producing different types of volcanic mountains. And I expect that you'll be able to put some time into that and research those topics, and you'll become more informed on those issues.